Welcome everyone to the next lesson in the full-time godev program, and today we're going to discuss some advanced techniques in types with Go, right? Very important stuff that I'm basically using all the time, and I want you to know also, right? So I switched back to VS Code because I think it's a little bit better for the eye for you guys and than other stuff, right? And I think most of you will also use VS Code. I'm using the Vim key bindings, by the way. Which is very convenient, and I recommend you to use that also, right? You're gonna be slow first, but you're gonna be faster at the end. Trust me, trust me. All right, so basically the first thing we're gonna discuss is basically strict embedding, right? So why strict embedding? What is strict embedding, and why is it important? Instead of giving you some theoretical explanation, I'm going to give you an example, right? So let's say we're gonna have a type, and that's gonna be an entity. Entity, that's fine, and there's going to be a structure, and let's say we're going to have a name, which is going to be a string. We're going to have an ID, which is also going to be a string. We're going to have a version, which is also going to be a string, and we're going to give this a pos x. It's fine, pos x can be like this. It's going to be an integer, and it's going to have a pos y, which is also going to be an integer, right? This is our entity. All good, all fine. So if you want to print out this entity, we can go here, and we're going to say something like fmt print f. We're going to say percentage plus v, new line, and we're going to print out our entity e, which we need to construct. So we're going to say n entity. We're going to give this a name, which is going to be my entity. What's going on here? It's choking. My entity, we're going to give this an ID, which is going to be ID1 or something. Actually, to be honest, let's make it a space. And then we're going to say it's going to have a version also. Yeah, I'm going to say version 1.1 or something. And then we're going to give it a pos x, which is going to be 100, and a pos y, which is going to be 200 or something. It doesn't really matter. So now we have our entity declared, and we declared it as a pointer, but we could just do it without a pointer. I'm gonna cover pointers in one of the next lessons for sure. So let's print out this entity here. Let's do go run main.go here real quick. Boom, and you're gonna see my entity printed out to the screen. ID is 1, version, and all that stuff, position X and position Y, right? No big of a deal, right? So that's all fine, but the problem can arise in your programs if you want to make another entity, but that entity is kind of special. For example, you're going to say type a special entity, right? And there's also going to be a string, by the way, and we're going to say that basically in our special entity, we want to have the same field members as entity, but we want to add an extra. So what the first thing we need to do is basically copy all these things, paste them in here, right? And then we're going to say special field, which is going to be an integer or something, right? Actually, to be honest, let's make this a float 64, right? Because it's a special field. So you can already see it coming. We have basically duplicated data, right? We have data here in entity. We have a special entity which also has all this data, but it has an extra field, which is a special field. You could say we don't make a special entity and we put everything inside of entity, but then we're going to use a structure. Sometimes we're going to use an entity, and all the special fields are basically not filled in, so it's a waste of memory. And maybe we want to have like 100 different kinds of entities, and then our one entity is going to be very big, right? And if we have 100 different kinds of entities, and we want to change, for example, yeah, but I don't like name, this should be a username or something, I don't know, whatever, or something else, or this ID, we're going to make it public or something, then we need to update that everywhere. And that's basically bad news, because if we have 100 special entities, we're going to have some work, right? So that's where strict embedding comes in, and that's basically very simple. What we could do is basically delete everything in special entity here, right? So now we only have special field, but instead of copying all the fields from entity, we are going to embed entity just like this, a single keyword inside of our strict entity, and that basically going to inherit all of the field members from entity, right? Without we needing to specify them. So let's, instead of making an, let's delete all this stuff here. And let's make this a special entity, right? Special entity, right? And we're going to say that our special field is going to be a float, let's say 8888 or something. And if we print that out here, then we're going to see that we have an entity embedded in our special entity. And the only thing we did was setting the special field to 8888, right, as a float. So how can we, there's a couple things we can do. First of all, we can specify the entity we embedded in the kind of struct constructor, struct initialization method like this. But then we need to specify entity, right, which is going to be the exact same name as the one you embedded in here, right, the exact same name, right? And then we're going to say that this entity is an entity, and now we can fill in the variables, right? Name is going to be my special entity, right? We could say version is going to be 1.1, and then I think we have an ID also, my special ID, and that's it. And of course we have a pos X and a pos Y. So we could say pos X is 100 and pos Y is 200, just like that. So if we now print this thing out to the screen, let's clear it first, let's print it out. Double, boom, just like this. Now you can see that we have these values inside of our special entity. And we can easily access them, right? We have our entity here, E. We could say directly specify all these members that special entity has inherited from entity, right? You could say ID, just like this, right? You see, boom, it's printing out my special ID. We could give it a name and then run this again, right? My special entity. And we could give it a pos X or something. Look at this, pos X, and run this again, and we're gonna have all these values, right? So this is one way to initialize that, but what we also could do is basically, let's delete special ID here, right? Let's delete ID. So if I now print out ID, it's going to probably be blank, right? Look at this, boom. It's not then because we deleted it. We can also specify it like this. E.ID is basically my special ID. And then do it again, boom. You see? So you could either do it like this, right? Initialize it like this, or you initialize the fields like this, right? E-name is gonna be foo, for example, so we're gonna overwrite this. So if we now say name here, then it's gonna be, did I save this? Foo, exactly, you see? That's that. And we can take it a step further because look at this, we have position X and position Y in entity, right? So how can we fix that? Well, we can do something like type position. That's going to be a structure, right? And we're going to say that there's an X and a Y is going to be integers. And instead of pos X and pos Y in entity, we're going to delete that and we're going to embed the position inside of entity, right? So now in our special entity here, this pos X and pos Y is not going to work anymore. Why? Because it's not anymore a pos X, pos Y. It's a position right now. So now we're going to say that position is going to be a position. And then we can specify the X to 100 and X and the Y to 200, right? And then we can actually basically go run main.go here. And wait, we don't print out the entity, but only the name. Just like that. Boom. Now you can see we have a position of X and Y. And the cool stuff is, even though that position is embedded in entity, we can directly access this, right? You could say E position, but you could also say E.X is 333, right? So we could do EX here and print that out. Oh, what's going on here? That's not a good idea to do. Let's run it manually actually. Go run main.go and you could see that it's 333, right? And you see where it's going. You could modify the X, the Y value, which is 111, for example, right? Let's print out the position. You see, X 333 and 111. You see, so this is handy because right now, if you want to change something in position or in entity or something, we just need to modify this and it will basically reflect on all the structures that are basically embedding or inheriting from that other structure we placed into that struct, right? So that's basically struct embedding, right? Very simple technique, very interesting, removes code duplication and all that stuff, right? The next thing I'm going to show you is a very nice trick I'm using. So I'm going to delete the screen here, just like that. Let's make a func main. Boom, just like that. So, for example, let's say we're going to make an enum, and we already covered this, right? But I'm not quite sure if I covered this in depth. So I'm going to do it anyway, and it's basically the stringer method. Look at this. So let's say I'm going to have a type, and it's going to be color, right? Let's make it a color, and it's going to be an integer, right? And then I can say const, right? This is how we make enums. Then we can say color blue. It's basically a color, and we're going to say iota, right? For example, like this. And iota basically means that increment everything below, right? So if you say color black, you see we only need to specify color for the first one, specify iota, and everything below this will be automatically incremented, right? Color black, color yellow, and let's make another one, color pink, for example, just like that, right? And let's say fmt println. Let's print me the color is, and we're gonna say color blue, right? You see color blue here, and if we run this, we're going to say that the color is 0, right? And that's because blue is basically the first one in the constant list, right? So it's going to be, iota is going to be incrementing, but it starts at 0, right? So color black is going to be, color black is going to be 1, exactly. So if we run this again, you're going to see that the color is 1. But that's actually annoying, right? Because color is 1. If you come back into this project 10 days later or 2 months later, nobody, what the fuck, color is 1? I don't remember what color is, right? And you don't want to basically go back into your code and check, oh yeah, black is the first one. It's annoying. It's hard to debug. So what you could do is implement the stringer interface for color, right? And how do we do that? It's very simple. You could say func c color. Then we're going to say string, right? And string is going to return a string, and we could say switch based on C. We're going to switch on this integer here, because C is going to reflect to this integer, and we're going to switch C, and we're going to say case color black, right? Let's copy duplicate this a couple times. We're going to say color black, color yellow. What do we have here? Pink. We blue, black, yellow, pink, right? Just like that. And maybe we could do a default case here, and we're going to say panic invalid color given, right? Just like this. So if it's blue, we're going to return, basically, you could capitalize this, right? And for black, you're going to say return black. We could even return color codes, hexadecimal codes. It doesn't really matter. You can do whatever you want. In this case, I'm going to return strings here, color yellow, and for pink, we're going to basically return pink here, just like that. And if we print out now, right? If we run now, you could see that the color is black, right? It's not 1 anymore, it's black. It's because Golang, if you implement the stringer method, the string, right, is basically an fmt stringer. It's going to be an fmt stringer, right? If you implement that for anything and you print that out somewhere in println, printf, whatever, it's going to first try to find the string method and use that if it's implemented, right? And now we're going to have a nice string representation of our enums, right? That's the thing. Are there any other stuff I want to show? Maybe, not quite sure if I basically mentioned this, but we could do something like, we could do this, iota plus 1, for example, right? So if we do, it's going to be the same thing, probably, yeah. But the thing is, if you do iota plus 1, it's going to start from 1. And you could also shift this with some stuff, right? It doesn't really matter. There are some advanced techniques you could do with that. It's just going to output different numbers, but the constants are staying the same, right? Color blue will be blue, color black will be black. Doesn't really matter, but these are things you could do if you really want, but iota is fine, right? Yes, you could also do some other cool stuff, for example. But what I'm going to do is I'm going to make it a separate lesson. It's going to be interfaces, advanced techniques for interface. I think it's very important, and I don't want to make this video way too long. I think this is already some cool stuff you could play with, or you could play around with these embeddings, try some different stuff out, you could also, the cool stuff is, guys, by the way, that it also will inherit function names, right? Not only the variables, right? Let me quickly do this real quick. Let's say we have a type, for example, a player, which is going to be a structure, right? And let's make quickly a position here. Position, structure, right? We're going to say x, y, int, and we're going to give this a function, for example, p position move. It will return a string, it doesn't really matter. We're going to say fmt println. We could say move val is going to be an integer. The position is moved by val. Something like that, right? So now we have a player here. We need to return this thing. Actually, to be honest, let's delete this. Doesn't really matter. Let's make it just a function that print things out. It doesn't really matter. So this player is going to embed this position, right? And what we could do is here, we could make P is going to be a player, right? And what we could do is just call move. You see? We can call move on this player. Although we don't implement it move, the only thing we did is embedded position, right? It's also going to inherit moves, right? Let's say 1000. If we just run this, it will automatically print that out, right? The position is moved by 1000. You see? So this is already nice stuff to play around with. Try some stuff out. And I will see you in the next lesson where we're going to cover advanced interface techniques. Yes. Peace.